Hey, hi. So, welcome to BPEC YouTube channel. Let's try to learn about one Python interview question, which is asked in most of the interviews. So, which is related to dynamic programming. So, now here you are able to see this particular question. So, what exactly we are trying to do in this particular video is like we are going through this question and let's try to code this particular question. So, with our Python programming, so with the help of dynamic programming. So now here, let's try to see the question, what exactly this question is explaining us. A man wants to do rock climbing. So now, for example, let's pile all the rocks. So these are all the rocks, we have it. So now he is doing a rock climbing and reach the top of the steep peak. So now this is going to be our peak and this is the position, maybe like we are going from the ground. I think this is our position and we need to reach to the top of that particular peak. And if you look into it, there is a number of convenient rocks on the mountain, which the mountaineer can step on to reach peak at little easily. So now, in order to move from the ground, in order to reach to the peak, there are various, for example, convenient rocks. What we need to do, we want to jump from one rock to the another rock so that we are able to reach to the peak of the mountain. So now the initial position or the rock on which the rock climber is standing currently is denoted as I. For example, if you are trying to stand at this particular initial position, if this is your initial position, we can call it as I. Or if this is your initial position, we can call it as I. Or if this is your initial position, we are able to call it as your I. So now what exactly I is? So the initial position where you are standing can be called as your I. And then from each rock, the person can skip up at most X number of rocks. So now he is standing here. So now he is able to skip X number of rocks. Means like he is standing here. From this he can skip this 2, which are X number, the maximum. And he is able to jump into this position. So how you can jump? Maybe like you are having a mind-blowing shoe, or maybe like you are having a huge amount of fitness, maybe like, and even the distance from one rock to the another rock is also less. You are able to jump from your initial position, a maximum of this many X number of rocks, and you're able to get into another one. So that is the question. And the task here is to find the number of ways a mountaineer can climb to reach the peak. So now you need to identify the number of ways. So now what are the number of ways a mountaineer can climb to reach the peak? For example, he's standing it here. So now you're jumping to here. So first position, second position, and the third. So he's taking 3 ways in order to reach to your peak. So in this way, so what exactly we need to identify is the number of positions, or we can say the number of steps or the number of movements he made in order to reach the particular peak. So for this, we want to write down a code. So here they provided the number of rocks are available are 6. So 1, 2, 3, 4, 5. There are 6 number of rocks. And here 3 value of I. So the initial position is not here. So if this is your rock, so 1, 2, 3, the initial position starts from here. So he's trying to go. So he's leaving the 3 blocks, and maybe like we can say this, or third position we can write. So he's starting from the initial position is from the third rock, and the number of rocks he is able to skip the maximum or 2. So either he can skip that maximum of 2, or he no need to skip at all. So now when we are able to give it, and they said the output is 3 number of ways has been he can reach the peak. So now this is the output. So if you are giving this 3 parameters, we need to get an output of 3 number of rocks. So in order to do this, we want to write down a program. So like how exactly we can write it? So now in order to write down a program, basically we are able to go with, there are various programming techniques, like we got a dynamic programming, we got divide and conquer, we got recursive things, which means recursive programming. In this way, we got various approaches in order to write down your programming. So for this, it's better to go with your dynamic programming. The reason why we are trying to go with a dynamic programming first, in order to understand, so in order to know how many ways he is reaching the peak, so we need to understand how many steps he is making. So like he is at the third position, from third position he made 1 step. So he made another 1 step. He made another 1 step. So like we are trying to solve each sub problem, or we are trying to understand each step So by summing, okay, he made one step, one step, one step. By summing all this, each sub-problems, we are able to get the optimal solution of how many ways he is able to reach the peak. So we call it as optimal sub-construct. So now that is something which is there in your means like in your dynamic programming. And not only that, so we are going across each sub-problems, and each sub-problem related memory need to be stored. Why? So if you are trying to go back to your fourth step or to your fourth stone, again you don't need to rerun the loop again. The memory is already recorded. You don't need to go back and you don't need to rerun it again. So it's a waste of time and it's a waste of energy. So now that's what your recursive do. So what recursive do, it's going to keep on running the same loop multiple times. So but what exactly we are doing? Every output of the loop, we are trying to store it into an array so that if that particular step is already done, we don't run it. We will be calling that from our array. That is the purpose of your dynamic programming. So every sub-problem, whatever the activity we are doing, we are recording it as a memory. And next, so every sub-problem solution, we are trying to sum all that solutions so that we will be getting the solution of our final number of ways of reaching to your mountain. So we call it as optimal sub-construct. So let's try to create a code. So let's try to run the code here. Let's go to Jupyter. Let's create it. So now, the very first step is like, let me create a user-defined function. So which going to be defined. So let me give a name, ways underscore to reach the peak. So ways to reach, let me give ways to reach. And if a user is passing n number of rocks and I is the initial position, he can skip maximum of like x number of rocks. So for this user-defined command, I want to define a particular variable, maybe like I'm defining very simple, like it is means like number of ways. I'm calling it as NW. Number of ways is equal to, so 0 initial position. So why? So like when your rocks are empty, so let me clear all this. So whenever you have your rocks, for example here, let's take this, you got 6 rocks. And all the 6 rocks, the very first position, we are not making any move. So what exactly happens? All the 6 positions need to be 0. So like it may not be something it's going to run. So that's the reason 0. So multiplied by, so there are n number of rocks. So like n and plus 1. So why? So why you are giving that plus 1 is in order to handle your indexing. So indexing value starts from 0. Whereas the rock position, we are saying 1, 2, 3, 4. In order to overcome that, we are just going with n plus 1. So let me execute that. So now that is the user-defined function. So there is a lot more. Like first we created a dynamic programming array, NW0. Let's try to see what is this NW. So let me just copy this line and let me run it. And let's see how the output look like. So the n need to be defined. We are saying there going to be 6 stones, like there are 6 stones n. So based on, so this is a wrong code. So here you need to use parentheses. It cannot be a list. It need to be parentheses. Let me change it to parentheses. That's a mistake I made. And let me run. Yes, it's running NW. So like you got overall 7 zeros, you got it. Why? So there are 6 rocks. So like in order to handle that Python indexing, so we can skip that 0 part or whatever it is. So 0, 1, 2, 3, 4. Overall 6 rocks we have. Initial the position is 0. Why it is 0? We are not making any move at. We are just holding. So just like we created an array. So inside this array, we need to make every step we are doing, we need to record it inside this array. Wherever there is 0, that 0 going to be replaced with some other value. So now we created this. Now what I need to do, I want to initiate the particular value of this array. So I, so which is my initial position. So n means like NW of I is equal to, so I'm calling it as, for example, if you are giving I as, for example, that is your initial position. So now what is your initial position? 0, 0, 0, 0, 0. If I'm saying your initial position going to be 1, so now what exactly going to be? So now this ni going to be, so at the first position we will be recording 1. Now here I'm giving it as 1. So now if your I position is 2, the second index position going to be provided a value of 1. Why? You started your position from the second rock. So if you say give your I position as 5, so your position is started from your 5th rock. In this way, so wherever the position is, so if you are standing on that rock, we are calling that position as 1. So we initiated our position. Now I want to run a loop. So I in range, so I plus 1. So what is your I plus 1? So the initial position. So you want to run your loop. So now from your initial position, you need to move. So for example, you can see this. So if your initial position is 3, so from 3, you are trying to move your upward direction. So for that reason, so from 3, you are moving upward direction. So 3rd stone, 4th stone, 5th stone, 6th stone, you are trying to reach to your peak. Now in the similar way, let me write down the same thing. So for I in range, so now where exactly your I plus 1 and n plus 1 just for your indexing. So you are starting from I plus 1. So if you take it, your indexing ranges from 0. So like you are starting from 1st stone, 2nd stone. So I plus 1 going to be like your 3rd stone plus 1, 4th index. So like indirectly in your Python code, 4th index is your 3rd stone. So now in this way, now you are trying to give this, and I want to write another loop, nested loop. So why? So now we are trying to go with one step. So now we are able to, whether we are moving one step or we are trying to make a maximum number of jump. So means like whether we are trying to move one step from stone to stone, we are trying to make one step, or from stone to stone, we are skipping that 2 stones and we are jumping it. So for that, we want to write another loop. So for j in range, so now 1, either you are able to make the minimum step, we are able to go with 1. So, and the minimum of x comma, so like it starts from 1 step up to the range of, so like x is your maximum number of steps you are able to jump, means skip and jump. So now I is your position, where exactly you are standing. So minus, so like your I. So now this is going to be repeated. So now, for example, this I value going to change. So let me just print it and let me show you. So you will be getting an idea how this works. Plus 1, colon, and I'm saying dp, or here it is nw of, so I is equal to nw of, so I need to update it, is equal to nw of I minus j. And I want to return nw of n number. So let me just print it, whether we are able to get that output or not. So where n is equal to, there are 6 stones, and where your initial stone position, we are starting from 3, and we are able to skip of 2. Now let me see, are we getting the exact output or not? So ways to reach, let me copy and let me run. Yes, it is able to give the output. We are able to reach to that at 3 steps. Now let's see how this loop going to work. So we already created NW. Now I want to create NW of, so here I said I. So based on this data, I is 3. So 3 is equal to 1. Now if I print NW, so 0, 1, 2, 3, third index position, we started, so that 3rd stone position is like 1. So like we started our first position, our initial rock position is 1, yes. So whereas like from here we want to move. So in order to move, I created a for loop. So now the very first for loop is this. So for I in range, this, so let me just run this. So for I in range, I plus 1, n minus n plus 1. So where I going to be, your initial position is 3. And the number of rocks we have is 6. So now overall, I'm calling it as 4. And this going to be 7. And I'm just trying to print this. So we are trying to move from 4th stone, 5th stone, and the 6th stone. Why? We already at the 3rd stone. In order to reach the peak, we got the 5th stone, 4th stone, 5th stone, and the 6th stone available in our hands. We already at our 3rd stone position. So now 3rd, 4th, 5th. So like this 6th count, we don't need to do that. Why? So like the next one is the peak. So now if you are able to reach to the 6th, and the next one going to be your peak. So now we need to go across first one, Now there is another loop which is for j, this one. I want to run even this. So for j in range 1, minimum value is like 2. At most we are able to go with 2 steps. We can skip it. And where I value is from here. So the first position of I going to be 4. And the second position I going to be started from your third position. So, and then I'm saying print of j. So now it's going to be 1. Now, for example, for the very first time, when your I value is 4 and when your j value for your fourth stone position, j value going to be 1. Now I want to update this array need to be updated. So in order to update, we have written this small command. So nwi, so this one, nwi, where I value is 4. And here nwi minus j, so where your I value is 4, minus j value going to be 1. And let me run it, and now let me print nw. Now you can see we made another move. So like, so we are at stone 3 and we made another position to stone 4. Now again I want to make another move. So now again if you go back, now what exactly happened? So how exactly this nested loop runs if you go back to this example here. So now we are trying to run this particular nested loop. So first, we will be running all the elements inside this particular range. Once all the elements inside this elements are executed, then what we are doing, we are trying to go back to this. We are going to the another element in this particular loop. And then based on the second element, again we are running all the elements inside this particular j. Again we get back. So in this way, all the elements of this outer loop are completed. We keep on running the particular command. Now let's go back and let's see. Now here in j, we have only one value. So if you see in j, we have only one value. So only one step we made it. Now in order to make another step, so we want to go to your range. So now fourth is done. We are going to the fifth step. So now here minimum x is equal to x equal to 2. And this value going to be, for example, this is your, if you go back to your equation, it is I. So now I going to be now, it is 5. So 5 minus, and this going to be your I, which is your initial position, which is 3. If I print, you are able to get your j value as 2. Now here, if you look into this equation, so now this value need to be nw fifth index position and nw 5, and this is going to be j going to be 2 now. So now already j of 1 is already done. So it's already complete. You don't need to go back and rerun that one more time. So like again, you are trying to, if you want, you can just go back and you can do it. So I'm just trying to go with the second one. And now if I run, again, you're able to make another move. So now in this way, like we are at third stone, fourth stone, and the fifth stone, and the sixth stone going to be your peak. So overall, in order to reach the sixth stone, so how many steps it is taking? It is taking overall 3 steps in order to reach to your goal. So in this way, like we are able to run a loop, we are able to create it, and this is how your code is running. I hope you got an idea. Whenever you are writing any of this coding, so you have, whenever you are getting a problem statement, you got various problem solving approaches or programming approaches. You need to identify which programming approach you need to go with. So that's the reason you need to read about recursive, like what is that, greedy, all this you are trying to understand, and based on that you are trying to go with which one makes sense to my problem. So how can I take this problem, how can I solve it before you are coding it? So like normally this works for when it's not in a coding challenges, like when you are doing it in your practice, like before you are doing a lot of this coding challenges, like in order to do it in a quick time, so first you need to spend a lot of time on understanding it, breaking down. So like taking every problem, understanding it, so like solving like this. Once you got this approach very good, once you solve like this, once everything is running, now automatically, like when you see a problem, the approach going to come into the brain and automatically you're able to write the code. So for that reason, you need to spend a lot of time on coding challenges and understanding or breaking down the code, understanding the idea behind every particular approach, why we are going for it, in case if there is a possibility, changing with another programming approaches and seeing how they are working. So try to give in this way. In case if you like this video, if you want more, please comment it in the chat, so that in the comment section, so that I can make more videos similar to this on different programming questions, so that we are able to discuss here in this channel. In case if you like this content, please do subscribe to this YouTube channel. Thank you so much.